So to find trig limits, we don't have too many tools yet, but one of the best tools is the squeeze theorem. Now the squeeze theorem is great, and so we have all these conditions. Basically, what we're doing is we're looking for the limit of our function f of x. So the one that we're interested in is f of x, and so what we do is we find two functions, h of x and g of x, that surround f of x. And then what we say is that if that's the case, and then if both g of x and h of x have at a the same exact limit, then the function f of x, which is in between those two, would have to have the same limit. So let me show you a picture of what the idea basically is. So you have, let's say for example, g of x, it's wiggling around, something like that, and it's like this, and then you have h of x, and it's wiggling around too. Oh, wrong color. Sorry. Wiggling around. Something like that. And let's say that my value a is right here. And so what we're saying here is that f of x is always in between the two. Okay, so since it's always in between, it has to go through right there. And all you're saying here is it has to be near a. So it could be, bigger or less than, so it doesn't have to be always in between. So for example, it could, come down here. But all we're saying is that near a, it's always in between. So then, if g of x and h of x have the same limit, then of course it has to look like this, right? They have to approach this same value. Well, since f of x is always in between the two, then they also have to have the same exact limit, L. So that's the idea, and so it makes sense when you think about it graphically, but in practice, sometimes it's a little difficult to find the two functions that are in between and squeeze them. But this, has a lot of theoretical applications. And so let's do an example. Well, let me actually leave this here. Okay, so let me just... Okay, so I've got example. Let's say we're trying to find the limit as x approaches 0 of x times cosine of 1 over x. Okay, so notice that if we do our usual plug it in, we plug in here, we would get 0 times cosine of 1 over 0. That's going to infinity. Now what's cosine of infinity? Well, cosine just keeps going up and down and up and down. So this guy doesn't actually doesn't exist. So we have no idea what's going on. This isn't an indeterminate form where you divide stuff and factor and do all that stuff. So for trig limits, usual strategy is to use the squeeze theorem. Now what we need to do is two things. We need to find the two functions that are functions. So here, if I'm sort of using this as a framework, this is my... Oh, wrong color again. This is my f of x. Okay, so now I'm looking for the two functions that it's surrounded by. And a good starting point is to say, hey, well, I know that cosine of 1 over x, no matter what, is going to have to be between 1 and -1, right? Okay, so then what you can do is if you multiply everything by x, then what you get is that x is less than or equal to x times cosine of 1 over x is less than or equal to x. Sorry, this is negative x. Okay, so then you know that x cosine of x is always between positive x and negative x. Okay, so that was the first step. That's the first thing to show. And then what we need to do is we need to find the limit as x approaches 0. So here's step 2. Limit as x approaches 0 of g of x, which is this guy, and that's equal to 0. And then we need to find the limit as x approaches 0 of h of x, which is this guy right here, so x. And that's also equal to 0. So because these two are equal, and we know that our function is always between these two functions, then what we can conclude is that the limit, so then the limit as x approaches 0 of x times cosine of 1 over x is also equal to 0. And if we draw a picture of this, let's draw a picture of this guy. What this looks like, this function, x cosine of x, is it's big out here, but then as you get closer and closer to 0, it starts going and then big again, and so not a very good picture. But here what it does is, so positive x looks like this, and then negative x looks like this. And so what's happening is it's getting squeezed right here by those two functions. And so at 0, as you get closer and closer to 0, this function is also going towards 0.